This is a nice question. So we've got some cubic here, curve C, y equals x cubed minus 16x plus 7. At 2 points on C, the gradient is 11. And if you, I mean, it's a cubic, so it's got a positive coefficient of x squared, positive coefficient of 1, so it's kind of going to be this shape. And at 2 points on it, we have tangents with a gradient of 11, like that. Okay, and they both have the same gradient. The tangents to C at these 2 points have equations in the form y equals ax plus b. They're going to, because they're straight. Work out the two possible values of b. Now, okay, first of all, if these tangents have a gradient of 11, then this isn't just y equals ax plus b, it's y equals 11x plus b. Because this one gives you the gradient, right? We normally call it y equals mx plus c, but it doesn't matter. Okay, so we've already found what the a is there. We need to find the b, and in order to do that, we've got to find out what the x's could be and what the corresponding y's would be, and then we can solve for the b. So what's going on here is we've got, let's say we've got some notional y-axis here. These pink lines cut the y-axis at these b's here, because this is the y-intercept. And we want to know what these possible values of b are, which means we want to find the y values here, here, and here. Now, we can find out what the x's are, because we can differentiate this function, and then we get another function, and that function will tell us what the gradient of this curve C is for any given x. So if we differentiate this function and then solve it for 11, then we're going to find the x's that correspond, here's our x-axis, the x's that correspond to here and here. All right, so let's differentiate. Dy by dx equals 3x squared minus 16. And we want to solve for 3x squared minus 16 equals 11, because we're looking for the points where that gradient is 11, remembering that dy by dx gives us the gradient function. That's the same as saying 3x squared minus 27 equals 0. We'll divide through by 3, so x squared minus 9 equals 0, and it may look like we can't factorize this any further, but it's a difference of squares, so it's x plus 3 x minus 3 equals 0, and that tells us that x is equal to 3 or x is equal to minus 3. So we know that in fact this point is minus 3 and this is 3. So we've solved for our x's. We've got our a in this y equals ax plus b, but we haven't got the y's. But we can find those, because if we plug minus 3 and 3 into this function here, we will get these y values here and here. And then for each of those, we'll have an equation y1 equals 11x1 plus b, and we'll know what y1 and x1 are, so we can find b. And we'll have y2 equals 11x2 plus b2, and we can solve then for the other b. And that's the plan. Okay, so let's make this clear. For x equals 3, we have y equals 3 cubed minus 16 lots of 3 plus 7. And you should put this in your calculator, but that's 27 minus 48, which is minus 21, plus 7, which is minus 14. And for x equals minus 3, we have y equals minus 3 cubed minus 16 lots of minus 3 plus 7. And that is minus 27 plus 48, which is 21, plus 7 is 28. So now we've got two sets of equations. One where we're using, in this case, we're using 3 and minus 14 for the x and y values. And in this case, we're using minus 3 and 28. And we're going to put those into this here and find the different b's that we get out. That is the idea. So we'll start with minus 14 equals 11 lots of 3 plus b. And then we're going to be taking away 33 from both sides, and that gives us, let's say, implies b equals minus 14 minus 33 is minus 47. And then we've got another one where it's 28 equals 11 lots of minus 3 plus b, and that implies that, let's get this right, so this is going to give us minus 33, so we're going to have to add 33 to both sides, and 28 plus 33 is 61. So this implies that b equals 61, and they're the two values of b that we could possibly have, minus 47 and 61.